Good morning, all of you. Let us start with our deadlock prevention in OS. Okay, in the, what is the need for deadlock prevention? Let us we have already familiar with we have three. There are four necessary conditions for deadlock. That is mutual exclusion, hold and wait, no preemption, and circular wait. What is deadlock prevention? Why we need deadlock prevention? In general, for an example, let us consider a chair with four legs. For a chair to stand erect, we need all these four legs. It is similar and deadlock prevention also. The four conditions above is is needed for deadlock prevention. We can elaborately discuss about deadlock prevention by examining each necessary condition separately. Let us consider mutual exclusion. This condition must be hold for non-shareable resources because a printer cannot share simultaneously for several process. But yes, it is a shareable resources we know, but it requires mutually exclusive access and cannot be involved in deadlock. A good example is read-only files because if it shares the several process and open it read-only file. So in each and every system, we can open the same file in a read-only mode, but we cannot edit or we cannot say. If we want to save that file, we have to use it as an editable format, and we have to save it in that local system, and we cannot edit in the primary data. Similarly, in mutual exclusion, we cannot share the same printer with immediately. But if we need immediately, we have to install another printer for that. Similarly, at the same we, this only one file at the time. We can print only one file at the time, and the this process is need not wait to for the so if a process need not wait for a shareable resource, deadlock cannot be prevented. For mutual exclusion condition, there are some resources and which is not shareable. And in hold and wait condition, the condition occurs when a process holds a resource and it is also waiting for some other resource because already a resource is given and it needs some other resource which is already held by some other process. So till the process relieve the resource, the process must hold the received resource and also wait for that another resource. This is called as hold and wait. See in the diagram, a resource R1 is already allocated and it is waiting for resource R2. This is called as hold and wait condition. But in this condition, the hold, according to the each process must request and get all the resources before its execution is the primary role. But in such cases, deadlock occurs only when all the resources are not provided in a time sharing or a shareable system, multi processing or multi user system. We cannot share all the resources to one resource because of deadlock. The second protocol always allows the process to request resource only when it does not occupy any resource. And if two when we consider a process, it copies data from a file on a disk and sorts the file, then prints the result to the printer. If all the resource requires at the beginning of the process, then the process requires a DVD drive, disk file, and printer initially. If in if they if they hold if it will hold the printer during its entire execution, and even though printer is needed only at the end. This is impossible, right? All the state the printer will not be, even it is not printing any document. If the resource get the is shared with that process, it has to wait for the condition to work. In the second method, the process to initially only what the resource is needed, and it will wait for that another resource till it need. And this is the second condition. But is there any disadvantage with both the protocols? Yes, utilization of resource may be low since the resource must be allocated for a long period. We can release that a DVD drive or a printer to some other resources and at the beginning of the protocol, and it is possible for when the resources needing the when the resources needed by the process we will not get back. So these are all the drawbacks of this resource, because see when we need it we have a DVD drive, we have a printer, and for that process initially, but we need printer at the last time, and we need the DVD drive initially. If the DVD drive is used to some others, we cannot open the file, and at the end we only we need the printer, but initially if the printer is not given, that must be wait for the another process to complete that process. So this is always allocated to some other process, and this is used for hold and wait condition, no preemption. This is the necessary condition that no preemption resources already been allocated. That is this if the process is already holding the resource request, another request, and the resource cannot be allocated, it must release all the resources. If if a DVD drive is allocated and no printer is allocated, from in the previous example, then we have to resource the DVD drive also. In the if the second condition, in the second protocol condition, if we are having a DVD resource, and if it is check it is which process is using that, and if the DVD drive is completed, then only the second process will get that according to the operating system for the waiting process, and this resource is being this is so till that previous process which is using the DVDs must wait to allocate that process. This can be applied to some resources who can state easily and restore for CPU register, memory space, X. And the fourth necessary condition is the deadlock. Deadlock and deadlock circular wait. That is the priority number to we have to assign the priority number to each each resource, and which we cannot request the resource for lesser priority, and that each process must be required resource that is being utilized by another process, and whichever is having the highest priority will be allocated first. Then if the priority is very less, the priority number is very less, we cannot even get. This is the drawback with this prevention. And in general, if for the mutual exclusion, the practical implementation is not possible, because all the approach used is condition for schooling, and hold and wait it is also not possible, because all the resources must be given to that process initially. This is also not possible. No preemption. It is also the condition that all the resources from a process must be picked and given to that specific running process. It is also not possible. And in the circular way it is only possible as if the priority is higher only, the process the resources for that process will be applicable, and this is only the practical implementation condition for this. So this is the main condition with deadlock. Four main conditions. This is the thing with Poland. So do you have any doubts? Okay, then let us continue with the next class.